Hello, my name is Muhammad Amir Razid bin Hamdan. Number matrix 01 DGU 23F1020.
Hello, my name is Muhammad Azan Nesa. My matrix number 01 DGU 23F1015.
Hi, my name is Akid Amaisha bin Herianto. Number matrix 01 DGU 23F1023. Chapter 2. What is differentiation? Differentiation is used widely in solving problems, especially in engineering, medical, commerce, agriculture, and many other fields. Differentiation concepts are applied in displacement and velocity, displacement, acceleration, and time. The rate of change of vertical height with respect to his horizontal height. This rate of change of vertical height with respect to horizontal height is called gradient. As we can see, gradient equals to change of vertical height over change of horizontal height. The first rule of differentiation. First, multiply the index of x with the constant for x. Second, decrease the index of x by 1 unit. Thus, if y equals to x power of n, then dy over dx equal to n multiply x power of n minus 1 for all values of n.
Stationary point. We can use the second degree differentiation this point when the gradient a point is 0. It's called a stationary point or a turning point. You can see that the point of the left is a minimum point and the middle point is a maximum point. You will now be introduced to a special stationary point that is not a minimum or maximum point. We call this the point of the right in inflection.
Okay, so here we are looking at the example of application of differentiation in real life. In mathematics, we can do it in physics to build a rocket or to fix or build a car. Or in economics, differentiation can be used to calculate the rate of change of ordering and transportation costs for the components used to manufacture a product in which the cost is dependent on the order size. In biology, we can use it to find a birth rate and can predict the percentage of death rate. Also, we can allow biologists to predict whether the population is growing fast and countermeasures should be taken to slow down the growth.
Question 1. Use differentiation to find expression for dy dx. Number 2. Find the coordinate of any stationary points on the curve. Number 3. How many does the stationary point does the graph have? Number 4. Determine x-intercept and y-intercept point. Number 5. Determine the nature of any stationary point you found in part 2. Justify your answer. Number 6. Sketch the graph of the curve. For two questions that we choose is E and C. For question E, y is equals to 4x cubed plus 9x squared minus 12x minus 5. For question C, y is equals to 4 plus 12x minus 3x squared minus 2x cubed.
Solution for question E, where y equals to 4x cubed plus 9x squared minus 12x minus 5. Step 1. Find dy over dx. dy over dx equals to 12x squared plus 18x minus 12. Then dy over dx equals to 6 bracket 2x squared plus 3x minus 2. After that, dy over dx equal to 6 open bracket 2x squared plus 4x minus x minus 2 close bracket. And then dy over dx 6 open bracket 2x open bracket x plus 2 close bracket minus open bracket x plus 2 close bracket. and then dy over dx 6 open bracket x plus 2 close bracket multiply open bracket 2x minus 1 close bracket, and then we got the answer x1 equals to 1 over 2 and x2 equals to negative 2. Step 2, when x1 equals to 1 over 2, find the y. Y equals to 4x cubed plus 9x square minus 2x minus 5. And then we got y equals to 4 open bracket 1 over 2 cube plus 9 open bracket 1 over 2 square minus 12 open bracket 1 over 2 minus 5. We got the answer y1 is negative 33 over 4. Meanwhile, when x2 equals to negative 2, y equals to 4x cubed plus 9x square minus 12x minus 5. And then y equals to 4 bracket negative 2 cubed plus 9 bracket negative 2 square minus 12 bracket negative 2 minus 5. And then we got y for 2 is 23. And then we got stationary points for x1, y1 is 1 over 2 and negative 33 over 4. For x2, y2 is negative 2 and 23. Step 3, use the d square y over dx square to find minimum point and maximum point. D square y over dx square equals to 24x plus 18, when x1 equals to 1 over 2, d square y over dx square equals to 24 bracket 1 over 2 plus 18. So the answer is d square y over dx square equals to 30. So the 30 is more than 0. This is minimum point. Meanwhile, when x2 equals to negative 2, d square y over dx square equals to 24 open bracket negative 2 close bracket plus 18. So the answer is d square y over dx square equals to negative 13. So negative 13 is less than 0. So this is the maximum point. Step 4, sketch the axis y and axis x. x1 1 over 2 and y1 negative 33 over 4 is the minimum point. And x2 where negative 2 and y2 when 23 is the maximum point.
So for the first question, y equals to 4 plus 12x minus 3x squared minus 2x cubed. So the first step is we need to derivative it, and the answer is 12 minus 6s minus 6s squared. And lastly, we will get the answer for the 1s is negative 2, and for the second s is 1. So we move on to the second step is when x1 equals to negative 2, we substitution it to the first function, and we will get the answer for y is negative 16. And for the second s is when second s is 1, we substitution it as to the function and we will get 11. Therefore, the stationary point we will get negative 2, 16 and 1, 11. And we now test it second degree differential. dy over dx equals to 12 minus 6s minus 6s squared. We will get for second degree is negative 6 minus 12x. At the point of the first s is negative 2, we will substitute it to the second degree function and we will get 18 over 0. That is a mean point. At the second point for the s is 1, we will substitute it to the second degree function and we will get negative 18 below 0, and it's a max point. And for the next step, we need to sketch the curve of the diagram, and we can see is that negative 2, 16 is a mean point and 1, 11 is a max point. And for the last slide is summary of application of differentiation in real life. The concept of a differentiation, a fundamental idea in calculus, has numerous real-life applications across various fields. We realize it now that the concept of application of differentiation is very important in real life. It can be implemented to sort of other things such as physics, engineering, economics, and finance. Lastly, this application shows how the differentiation extends beyond mathematics to solve practical problems and optimize systems in the real world. I think that's all from us. Thank you from the bottom of our heart, and we would like to see you each other again. Bye.